Hmm. Good evening, Charan.
Good morning, sir.
Good morning. Just within 1 minute, we are starting with the class. Just hold on.
Obviously.
Good morning, everyone.
Good morning, sir.
So,
Good
in the
morning,
last
sir.
class, we were continuing with our discussion. We had various long discussions on contact, non-contact forces. We had our discussions on balanced and unbalanced. Okay. Today, we would like to continue or extend our discussion to pressure. So in this class, we'll extend the discussion to pressure. Also, you are requested, all of you, to attempt your test. A test is already live for class 8 on force and pressure. Okay, so you can attempt that test after the class, or you can even start. If you have not attempted, you can attempt it after class. The test is only for 20-minute duration. So once you log in, once you start the class, then finish it and then only leave. Okay, so let's continue here. Now today we are again going into a little bit more of pressure. We had already started with pressure. Let's see. So what does, let's see, pressure. Thank you. अच्छा है. So let's see the pressure. We say pressure. So why we need to define a physical quantity, and the physical quantity where we have the effect of force depending on the area. So we say here pressure is the force per unit area. We define pressure as force acting per unit area. And this force we also call as a thrust. Okay. This is called as the perpendicular force. So the perpendicular force acting per unit area is called as pressure. See, we observe in our life, we observe at different places that the effect of force is dependent on the area. So the same force can do different work. Effect of force depend on area. It's something like this. Suppose you want to prick a balloon. You want to prick a balloon, and let's say you require certain amount of force. If I say, so it's not always necessary that you will be able to prick the balloon with the same amount of force. Sometimes you may require a smaller force. Sometimes you may require a bigger force. It depends on the area of contact. Okay. So we observe here pricking of balloon in the last class, I showed you certain examples also. Let's see. You can say here pricking of balloon. I'll show you some of the examples where we have applications of pressure. So from the formula, just if I have a look over here, force acting per unit area is called as pressure. So by this definition, I can write the pressure to be equal to perpendicular force perpendicular or perpendicular force per unit area. Force by area will be called as pressure. And if we talk of the SI unit, so SI unit of force is Newton. Force is measured in Newton as the SI unit, and area is measured in meter square. So we call this pressure, we measure this pressure as Newton per meter square, which is also called as Pascal. So force will be measured in SI units called Pascal. There are, apart from Pascal, there are other units of force also.
Sir, 1 atom.
Yeah.
Sir, we measure in atoms.
Not atom, atmosphere. Okay, it's atmosphere. Okay. So SI unit is Pascal, but you have other units like I told you, bar, atmosphere, which is shortened as ATM. ATM means atmosphere. Then other units are like centimeter of mercury, or you can say millimeter of mercury. So centimeter of mercury or millimeter of mercury, generally the atmospheric pressure, one atmosphere, one atmosphere is equal to 760 mm of mercury. And this is roughly equal to about 10 to the power 5 Pascal. The amount of pressure exerted is equal to 10 to the power 5 Pascal by the atmosphere. So it means that if you have a unit area, so on your head, everywhere on the surface of the earth, the atmospheric pressure is equal to 10 to the power 5 Pascal. So it simply means that if you have anywhere the atmospheric pressure, everywhere around you, the air that is there, the air column, it exerts a pressure on you. On the surface of the earth, you have an air pressure. Let's see. So on the earth surface, we know that surrounding the earth, you have a column of air which we call as the atmosphere. So at every point, we can consider a column of air, and this column of air exerts a force. So the column of air here will exert a force on the surface of the earth, and hence a pressure will be exerted at every point on the surface. And this atmospheric pressure, it also help us in maintaining the blood pressure of our vessels. The blood pressures of our body, they are in regulation with the atmospheric pressures. They are in equilibrium with that. If suppose you say, if the atmospheric pressure was not there, so our blood vessels will burst out. Since there is no pressure, so our blood vessels, they will burst out. Got it?
So can you just explain the thing that you wrote in red one more time because I'm not so sure about it.
Which one?
Everything that you wrote in red.
Okay. So this is the formula for pressure. By the definition, we have given pressure is force acting per unit area. So pressure is written as force by area. We have taken force in Newton, area in meter square. So Newton per meter square, that is the pressure exerted by it. Okay. So anywhere, if you want to find out, one thing we need to observe here, that pressure is directly proportional to force and inversely proportional to area. Inversely proportional to area means if you increase area, there will be less pressure. And if you decrease area, there will be more pressure.
Sir, so it is a pressure formula. And what is the second one, sir? That is Newton by M.
That is the SI unit. This is the SI unit we have found out. This is SI unit, Pascal.
Okay.
Okay, so Pascal can also be written as Newton per meter square. So either
Okay,
you
sir.
say Pascal or you say Newton per meter square. They both are same.
Okay, sir. And the above one is the formula
Formula.
for pressure.
Yeah, this is the formula for pressure. Okay,
Okay, sir.
okay. Now let
Yes.
us see here how the different pressure and everything works. So see here pressure on uh okay, pricking a balloon
The
if you
pressure on
observe.
bench.
Okay, yes,
So even like pressure on the bench.
pressure on
Bench.
H. Okay. See pricking a balloon. Here if you are pricking a balloon, you can see at which examples. If you have to prick a balloon, do you have to apply a small amount of force or a large amount of force?
Small amount.
Small amount
A
of
small amount
small.
of force. Okay, suppose if you have to again prick the balloon, but the pin that you have taken is not sharp. If the pin is blunt,
Need to keep a
okay,
lot
More
of
amount of
pressure.
force.
So more
More amount
force.
of
then
pressure.
you require more amount of force.
Yes, sir.
Okay. So clearly we can observe from this activity that pricking a balloon here it is dependent on the area of contact. So it is the pressure that is playing the role. Here
Sir,
it is
can
the
you
pressure
again
that plays the
explain
role. If you
atmospheric
have,
pressure?
yeah, I'm coming to it. I will explain it. Okay, we are just studying this. I will come back to atmospheric pressure once more. Okay, so don't panic. I will discuss about the atmospheric pressure. So first we are discussing this that how the area of contact affects the different activities. Depending on the area, you may require a small amount of force. Okay. If you increase the area for the same effect, you may require to apply a larger amount. So here, the effect of pressure is dependent on area. Like I in the last class, I also showed you some this image. If you remember, I showed you a man sleeping on pins. Okay, so
A
this
bed
was
of pins.
bed of
Pins.
pins. Okay, so we saw here the bed of pins, and in the bed of pins, I showed you this man who is lying over here on the bed of pins, and still there is no effect. The pins are not going into his body. Okay, so why the pins are not going into his body? The reason
Sir,
being, had there been just one pin or two pin, then it would have pierced through it. Now there are a number of pins, and because of the number of pins, we have added the area of each pin. And by adding the area of each pin, you see here, what we have done, if you add the area of all the pins, so area becomes bigger. Now, for the same force, if area is greater, there will be lesser amount of pressure that will be exerted. From here, we know the pressure is inversely proportional to area. Yes, Charantej?
sir, so when the area is bigger, so he'll not get that much pain, or he'll get a little bit of pain.
Yeah, if there is a large area, so he will get a very less pain. The pain will be very less. Okay, even suppose by some method, if we are able to make a very continuous arrangement of the pins, if the distance between the pins is very less, so there will be almost no pain to him. He will not have any pain. Okay, it's the just the if the pins are very close to each other, the area will be larger. And if you increase the area, if you increase the denominator, the pressure will decrease. Okay. If you see about the fractions, say I think all of you know about the fractions. Like I say, I have 1 by 2, 1 by 3, I have 1 by 7. So out of these, which one is the smallest one and which one is the biggest one? Can anyone tell?
Got the question, so can you repeat again?
See, I have given you three numbers, 1 by 2, 1 by 3, 1 by 7. So which one is the biggest number?
Sir,
1 by
sir,
7.
1 by
1
7.
by 7.
1 by 7 is the biggest. No. Out of the biggest number is 1 by 2. This is the greatest. And 1 by 7 is the smallest. See, this is the smallest number, 1 by 7. You can check your calculator and find the decimal value. Check by the decimal value that 1 by 2 will be greater and 1 by 7 will be smaller. Just check out everyone. 1 by 2 is 0.5. Right? 1 by 3 is 0.33. And 1 by 7 is 0.14. Okay. So which one is the smallest one? Yes, which one is the smallest one? Did you get the smallest one? You get this value 0.5, 0.33, 0.14. See?
Sir, the
Gagana?
smallest is 0.14, sir.
Yeah. So 1 by 7 is the smallest and 1 by 2 is the greatest. Okay. So how we compare the numbers? If the denominator is big, so the number is small. So the same thing applies here. In the formula, if the denominator is big, so pressure is small. If the denominator is small, so the pressure is big. Did you get here?
Yes,
Okay,
sir.
I will give you one question to solve out here. Let's say a question here. So find the pressure exerted by a force of 80 Newton on two surfaces, on two different surfaces. Each having a area of, so find that pressure exerted by a force of 80 Newton on two different surfaces, each having an area of uh, uh,
Sir, is this
0.02.
question like sir, is this question like moving a object in equal pressure of Newton, two sides?
No, it's not like that. You have two objects, and on the two objects, different forces are applied.
Okay, so not equal forces, different.
No, same forces. Same. Okay, you have
80 Newton. Okay.
yeah, 18 Newton of force is applied on this object, and 18 Newton of force is applied on another object,
Not the same object.
not the same object.
Okay, sir.
And this next one has an area of
It's
0.0004 meters square. So can you do this question?
Sir, the second one, once can you explain, sir? Second question.
So for your help, I'm also drawing the diagram here. You have two objects. Force is the same. So here on this, you have a force of, on both of them, forces are the same. Here force is 80 Newton, and here you have force is 80 Newton. But this one has area as 0.04 meter square, and this one has area of 0.0002 meter square.
There is it 4 lakh and 2000?
Yeah.
4 lakh is the first one and 2000 is the second one.
Okay. So as per the diagram, if I find out for pressure for this,
That
so pressure.
sir, first one is 2000 and the second one is 4 lakhs.
Okay. So here you put 80 over 0.04. That you get 8,000 divided by 4. So this is 2,000. You get here 2,000 Newton per meter square as the pressure. If you observe the here, so here you get the pressure as 80 divided by 0.0002. So you will get your answer 80 by 2, and here you have multiplied 10 to the power 4. So you get 40 and 40. So this is the Newton per meter square. This is the pressure exerted by it. Okay. So did you get the answer for both of them? See, there is only a small difference of their area. The difference of area is very small, and we observe in the first case, you have a very small amount of pressure, 2000. Here you have a pressure of
Sir, 4.
40 lakh Pascal. So you can see just by changing area by a very small amount, we can enhance our task. Okay, the amount of pressure that will be exerted, it varies a lot on the area. So in the similar way, you can assume, suppose you yourself hanging your school bag. Okay, so when you are hanging the school bag, we can do the same thing by changing the area of the strips of your bag. Let's say I showed you in the last class also. Okay, I'll show you here area of bag strips. I want to show. You see all the bag strips which are there, school bags. Generally, I want to see the school bags.
Thin school bag strips.
Yeah. See, so you have all the school bags. They are having a wider area. Can you see all the school bags? They have a wider area. And now I will show you school bags with thinner straps. With thin strips. So you have some school bags with thin strips. I'll show you. Like you can see this one. Okay. The strips of the bag are thin. So in such cases, if you have thinner bag strips, the area or the pressure exerted will be very less, very big. The pressure will be high. And just okay, let's do one question based on this. Okay, another question here. A school bag applies a force of applies a force of 60 Newton on the shoulders. Find the pressure exerted by the strips if the strips are thinner with area of, yes,
Sir, I'm not understanding how to solve these questions.
what happened?
Sir, I'm not getting how to solve these questions.
Okay, so just okay, see this, I will explain this again. Just look at this question, I will explain this. The
Yes,
strips are thinner with area of uh, 0.002 meter square. And the second one is the strips are wider with area of 0.05 meter square.
Sir,
Yes,
now we have to find how much Newton are applied in both of them, in the thinner
you
and
have you have to find the pressure on the first one and pressure on the second one.
okay, sir.
Okay. So pressure, you are given the area, you are given the force. Okay, use the
So
formula of pressure.
the pressure on
Yes.
the first one is 30,000 and the pressure on the second one is 1200.
Okay, see. So I think you can use the formula of pressure. P equals to F by A. Force is given to us. Force is given to us as 60 Newton. The area of the two cases are given. You have the bag with the thinner strips and you have a bag with wider strips. And okay, who was not able to get how to solve?
Sir, first one is 30,000, sir.
Second
Okay.
one is 1200.
Okay. So who was not able to solve it?
sir,
I think
yes, sir.
some, yeah, and last year.
Last year.
Okay, last year. So see, you just remember the formula of pressure, which is force per unit area. In this question, you are given the force as 60 Newton. So study, you have the two bags. You have one bag here with this strips. You have another bag with thinner strips, very thin strips like this.
Yes, sir.
Okay. So one of the bags has an area, this wider one has an area of 0.05 and this
Sir,
thinner one has an area of 0.002.
okay, sir. Yeah.
That this bag applies on your shoulders is 60 Newton.
Sorry, sir. Which is applying
It
60
applies a force
Newton.
of 60 Newton. Yeah, force applied is 60 Newton by the bag on your shoulders.
What the back, sir?
Yeah, both the bags. Both the bags, they are applying the same force. 60 Newton,
Okay.
60 Newton. Okay, so you can use here force as 60 divided by area, which is 0.05. So this you will get the pressure for the first one. In the similar way, use the formula for second one. So you will get pressure as force by area, which is 60 by 0.02.
For both the bags, we need to write like this formula, right, sir?
Yeah, you have to find the pressure for both the bags. See, find the pressure exerted by the strips if. So the first one, if the strips are thinner, so then what is the pressure? If the strips are thicker, then what's the pressure?
So we need to solve both the equations also, right, sir?
Yeah, you just solve it for the equations.
Okay. Yes, sir.
Understood?
Sir, I understood, sir. Thank you, sir.
Okay. So see, now we can also do about the atmospheric pressure also we have to study. So see, pressure is force by area and hence you find out the pressure. And after finding out, do put them with proper units. So you get here 1200 Pascal or Newton per meter square
So second
and
one is capital.
30,000.
Yes,
30,000
sir.
Pascal. Okay. So in which case you have the greater force, greater pressure. Which one will exert a greater pressure?
Sir, thinner strips.
The thinner strips.
Thinner
Thinner
strips.
strips.
Yeah, if you are using thinner strips, then the pressure exerted is bigger. It's larger. So that is why to reduce the pressure on your shoulders, we use bags made up of wider strips and not those thinner strips. You can assume, suppose your bags have strips which are like ropes. If you have just thin rope like strips, so the pressure exerted will be bigger. You will have greater force, greater pressure exerted on them. Okay. Now let us see. I hope everyone has understood about the pressure.
Yes, sir.
Okay. Another thing we can see, a sharp nail and a blunt nail. This is also an example of pressure. A sharp nail and a blunt nail. See. Just I want to show you which one will be better for penetration. I think this one shows a sharp nail and a blunt nail. You can see here you have two nails, and out of the two nails, one nail is a sharp and the other one is a blunt one, right?
Yes, sir.
So see, you can see the first one. If it's, I think if it's visible to all of you, so if you observe the two nails, here you have the first nail A, this is the second nail B. So in A, the first nail A, uh, so this is the first nail A, the second nail B. Now the first nail is a sharp one. This is a sharp one, and this one is a blunt one. Yes. So which nail will you use? Out of the given two nails, which
Sharp
nail
one,
will
sir.
you use?
Sharp
Which
one.
one?
Sharp one, sir. Sharp one.
Sharp one. Why the sharp one?
Because
Because
we
it
don't need to
exerts,
exert more force.
sir, it exerts more pressure, sir.
Yes, for the sharp one,
And
we
the
will
blunt
get,
won't and the blunt nail won't allow much force.
yeah, we have to apply a small amount of force, and with the small amount of force, we will be getting a large amount of pressure.
Yes, sir.
So with the small force, we'll be getting a large pressure. and hence we will use a sharp nail and not a blunt nail. If you use a blunt nail, it will not go into the wood.
Yes, sir.
Okay. Okay. So bye all of you. Whatever you have, if you have any doubts,
So can you
Sir,
show the
post this
first?
sir,
yes.
will you post this in the group?
Not in the group, but this will be available in the resources section on the
Oh,
WeXL.
okay, sir. Okay, sir.
So can you
Okay.
show me the first page, sir? The red ones. I didn't wrote that.
Okay, here, this one.
Yes, sir.
Yes.
I'll just
Sir,
take
can you explain atmospheric pressure?
In the next class. That will take around half an hour, so that we'll see in the next class. Okay, our next class will be based on atmospheric pressure only.
Okay, sir.
Okay,
Bye, sir. Thank you, sir.
bye.